Hello again. Alright, and this episode is about naming organic acids. Okay, so if it's an organic acid, what we have to remember is that we are working with the carboxylic acid functional group. Okay, so what we've learned previously about acids like hydrochloric acid, um, things are or sulfuric acid. Things like this are called inorganic acids. And the reason inorganic is because these things do not contain this organic functional group. Organic because it has carbon in it. So again, these are not organic, they're inorganic. All right? So if we want to have an organic acid, we're going to have something with this functional group. And then there's going to be an R group here. Remember, this right here is a variable. Right? This is a variable. So long as this little functional group here, this puzzle piece, so to speak, whatever is attached here, that's going to be the base name of it. And then what we would have to do is look at this part here and know that since this is the acid, we would just come up with a naming system for the acids. So let's practice with the simplest one. The simplest hydrocarbon we can think of would be methane, right? So we know here's methane. If something were to happen where this carbon here were to pick up oxygen and become double bonded right here, then we've got this part of the functional group. Carbon can have 4 bonds, 1, 2, 3, 4, so there's now only room for one more hydrogen. So this would be methane. And then what we do is we take the root part of the word, we then drop the ending, and we add oic acid. So this right here would be methanoic acid. Okay. Let me get this out of the way. Let's try that again. Let's try it with the next hydrocarbon. So we know we have ethane. Ethane we know is a 2-carbon hydrocarbon. So remember, these hydrocarbons, they're the basis for all of our molecules. Every molecule that we're working with, these hydrocarbons are the foundation. So again, we would need this carbon to become double bonded to oxygen. So you can see that these two bonds right here would have to switch up in this angle. These hydrogens would go away. This bond right here would sort of swing out at an angle right here. And again, these hydrocarbons, they're mixed with a whole bunch of other things that are in the atmosphere, that are in your body, in the solution, usually in solution, not just the atmosphere, and are mixing with the oxygen that's pretty much everywhere. So put our carboxylic acid group on the end. This carbon has 1, 2, 3, 4 bonds. This carbon has 1, 2, 3, 4 bonds. The 2-carbon chain we know is ethane. So again, remember, we drop the ending and we add oic acid. Okay? And let's take a look. Instead of going to 3, let's go with something different. Let's go with 1, 2, 3, 4, 5. 5 we know is pentane. Okay. So you know there's supposed to be hydrogens all the way around this, so I'm not going to take time to do that because you already know that that's the case. So we know right here, these two bonds right here are going to come together for our double bond, right? So these two bonds right here swing up, and we know that we get our double bonded oxygen. Here we have our hydroxyl group, and this whole thing together here is the carboxylic acid functional group. So now what we have with this one right here is 1, 2, 3, 4, 5, so that's pentane. Remember, drop the ending. Oic acid. Okay. And so now how do we write the formulas for these? Okay, so let's start up here. You start with the basics. We've got, see how we have COOH. That's always going to be at the end of the organic acid formula. And then you put the rest of the molecule. Well, the rest of the molecule is just as hydrogen, so we're going to come here, put a hydrogen in front, and this would be the formula, the compound formula for methanoic acid. Let's try that again. Here's the COOH. And then we put the rest of the molecule. So all of this right here, every bit of this is the R group. All of this is the R group. So that's CH3. So we come over here and we put CH3. And then there's our formula for ethanoic acid. And then right here, pentanoic acid, COOH. COOH. And then here is the rest of the molecule. All of this right here. All of this right here is the rest of the molecule. So that's 1, 2, 3, 4. So that would be C4. And then you have 1, 2, 3, 4, 5, 6, 7, 8, 9 hydrogens. So we come over here and we put H9. C4H9COOH. And that's it. That is, I don't care how big the molecule is. I don't care if it has extensions on it. It doesn't matter. You would always use the base name of the molecule, the long chain, the parent chain, and then go from there. I'll do there'll be another video that you can find that will show naming acids that have like substituent groups, the alkyl groups. It still follows the same principle. I'll do another one on that sometime in the future. Take care. Hope it helped.